Welcome to the discussion for 2.6 in Math 980. This section is titled Functions. So I've written a couple, the first two that we're going to talk about on the board. They're a bit long, so I didn't want you guys to have to fast forward through that. But number 2, let's start there. It says find the domain and the range of the relationship and then determine if it is a function, right? And so I've kind of given myself probably too small of a bit of room here, but I'll write, my answers here. For number 2, the domain is simply the set. So I'm going to open it up with a set bracket, right? It's just the set of all the x values, and you'll probably want to put those in, not probably, I'm telling you, definitely put those in ascending order, right? So the very smallest one, -5. And you can underline them to show that you've done it, but the next smallest one is a 0. And then it looks like a 2, and then a 3, and then I've got a 5 and a 6, and then my 12, right? And that's all of them. That's my domain, right? And I'm going to leave this here because I'm going to come back to it, right? But the range then is just all of the y values. So your range would be another set, open it up, and it's all the y values. So starting at -8, your smallest, your most negative, if you will. -8, and then 0, 1. 1 appears twice, so you don't have to write it twice, just write it once. And then 2, 4, 5, right? But I want to look at the domain for a minute because the last question says, determine if this is a function or not, right? And when I went through and picked out my x values, there were no repeats, right? I didn't see 5 input once and then 5 input a second time. That's a -5, that doesn't count. Since that doesn't happen, since there's no repeated inputs, there's no possible way that I could have one input go to 2 different outputs, and therefore this is definitely a function. As opposed to number 3, let's take a look at it. If I write my domain, the domain is a set of x values, and again I'm going to go in ascending order, so I'll look for the smallest one. Looks like my smallest one is a 2, and what do you know, that 2 appears twice, so ding ding ding, I probably have an issue, right? We'll come back to that. But 3, oh look at that, ding ding ding, 3 appears twice, double issue, right? But it's still part of the domain, so I'll list it. 3. Oh, look at that. 5 appears twice, right? There's issues all over the place with this thing. And then I've got a 6 and an 8. And then my range, let's write the range on this one because I have the room to. The range is -3. Is my smallest y. 1. 3. 4, 5, 7. Looks like that's it, right? Unless I've missed one. I don't think I have. But we've got all of these spots, right? 3 goes to 4 at one point, but 3 goes to 5 at a different point. That's an issue. 5 goes to -3 at one point, but 5 goes to +3 at a different value, so another issue. 2 again goes to 3 sometimes 2 goes to 5. Those are issues, right? If I have an input that goes to 2 different outputs, this is not a function. Not an FN. Maybe I should rethink my shorthand. Right? Not a function. And that's your answers for those two. All right. Let's take a look at number 6. So when we get to number 6, we're looking for domain, right? And so before we talk about that, the domain, if I have something like, say, whatever this polynomial is, right? There's no issues here. There's no number that I can't square, double it, and add 5 times that number to it, and then add 10 more. Every single number, every single real number I can do this to, right? So there's no issues here. Therefore, it's everything, right? For the problems that we're looking at, we're going to find those little bits of numbers that don't work, and that's where we're going to focus, is finding the numbers that we can't put into these things, and define our domain based on, well, we can do everything except these, right? So for number 6, it says find the domain of some h of x, which is the square root of x plus 8. Right? Our issue here is that I have a square root, and I cannot square root a negative number yet, right? I can't take a square root of a negative number and stay in the real number system. So that is to say that this x plus 8 is limited. Whatever this number is, it has to be at minimum 0, and that's my inequality that expresses that. And all I have to do is solve by subtracting 8. And that's my domain, right? This expression defines my domain. X plus 8 simply has to be greater than or equal to 0, and therefore x has to be greater than or equal to 8 is my domain. You can write that in interval notation, you can leave it like this, you can write it in set builder notation. I think the question asks you to put it into interval notation, so do that. Alright, let's look at 9, which I think is another domain problem. Right. So 9 is, I have another function, and I have 2 divided by x minus 4. Right. My issue here, I don't have square roots, that's not an issue, but my issue is that I'm dividing by something that has an x. So I need to make sure that x is not some number that will make that denominator 0, because I can't divide by 0. And again, that's all I need right there, is the denominator, which is x minus 4, simply cannot be 0. And I can solve this with the inequality symbol here, or unequal, just like an inequality, or just like an equality. If I add 4 to both sides, that gives me x cannot be 4, right? Which is, if you think about it, every number except 4. So if I'm writing this in interval notation, or even if I graph it, if I graph this, there's 4, it's an open, and it's everything but that one number. And so because there's this jump between the two, that is a union, right? If I write this in interval notation, it's forever to the left, so negative infinity, up to 4, and I'm going to union that with 4 to infinity. In interval notation, it's kind of a big, complicated expression when all you're just saying is not 4, right? But that's what it is. Everything up to 4, everything past 4, but not including 4 because we have it in parentheses. And that's 9. Let's look at 10. 10 is some function we're calling p of x is equal to 5 over the square root of 7 minus 3x. Now I have two issues in one. I have a square root, and all of that is in the denominator, right? So my two issues are the square root and the denominator. For the square root, again, it's whatever's under there, so the 7 minus 3x has to be greater than or equal to 0 to satisfy the square root's requirements. But for the denominator, this can't be 0. So that is to say that the 7 minus 3x itself cannot be 0, right? And I can solve these separate with an and, because I have to satisfy both. If I only satisfy one, it doesn't matter. If I fail one, if I fail having a 0 in the denominator, the thing still blows up, regardless of whether it satisfies this guy over here, right? But I can combine these things into a single one, because if it has to be greater than or equal to 0, but can't be 0, all I have to say is, instead of 7 minus 3x being greater than or equal to 0, this guy comes in and says, no, not equal to, and all I have to do is say it's strictly greater than 0, and that takes care of both of these, right? And then we'll solve. Subtract 7 perhaps, leaving me with negative 3x is greater than negative 7. Divide each side by negative 3, and that gives me x is less than, because I have to switch this, and I have positive 7/3. Right? And that's my domain, right? You'll have to take this, turn it into interval notation, but that would be your solution to number 10. All right, let's look at one last one here. Let's look at 13. Thirteen says we have a function h of x, and it's 3x squared minus 3x. Plus 4. And it wants us to evaluate a few places, so let's go h of negative 2. And I'll do the first two, I'll let you play around with the other two. Right? But it's here when people mess up, right? This negative. So I'm going to do the 2 first. We'll show you that one, because that one's fairly easy. That's just replacing all of the x's with a 2. So I have 3 multiplied by 2 squared minus 3 times 2 plus 4, right? It's this expression where all of the x's are now 2's. And I simplify following the order of operations, so I would do my exponent here first. 3 times 4 minus 3 times 2 plus 4. Right? Multiplication, so I get 3 times 4 is 12, 3 times 2 is 6, and then plus 4, and then I can just go left to right. 12 minus 6 is 6, plus 4 is 10. Right? So that one's pretty straightforward, you just have to watch those order of operations. It's still easy to mess up if you do an operation wrong, right? But this one here, I've seen this on every final ever, is probably this question followed by that question, right? And the reason is because when you plug in this negative 2, that negative 2 gets squared, right? It's a negative 2 in place of x, so that whole thing in parentheses is going to be squared. Minus 3 times negative 2 plus 4, and it's the signs typically right here that kill you, because negative 2 squared is 4, positive 4, right? Minus 3 times negative 2 plus 4, right? So you still get a 12 right here, but you get minus 3 times minus 2 is plus 6, and then you have that plus 4, right? So it's not the same thing. This is 12 plus 6 plus 4 as opposed to 12 minus 6 plus 4. So here I've got 18, 22 for my answer there. So watch the parentheses with the negatives, watch the multiplication with the negatives. That typically is why they throw this on there, because they want to just kill you with those order of operations and the negatives, right? All right. Thank you, and I will see you guys for 3.1.